So welcome back, Stella, for this second part. We're going to look at the B part, which says let's prove that 2gt equals to 1 on k ln of 5 of the absolute value of 5 on the 3. Is that okay? There is something I want you to note here. 16 on 15 is a positive number, so you can remove this absolute value. It has no use. The 5 on 3 is uh, um, a positive number, so they, even if this was a negative number, the absolute value will remove it. So it's not like it's a variable, we don't know its sign. So to prove this other one, we have time here. So what we have to do is the what? We have to write acceleration in a form where we will have time related to something. Is that okay? That's the best way. This is time. This time is already directing us. We have to write um, acceleration in a way that we are going to have a relationship with time and something. So we know already that. So let's go to our sheet. So we are to prove that in this next question, this B part, there's something also very important I want you to understand here. Look at something, because in the assignment I gave you in on projectiles, there were a lot of errors you did. You should understand something about reference, and I'll explain it better when I will be doing the chapter on projectiles. You should understand something about reference is that when I say at time t equals to 0, the question I will ask myself is, where is the particle? The particle is here. The particle is here at time t equals to 0. That's the question you have to ask yourself. At time t equals to 0, where is the particle? Here is the particle. Now, if I want to locate its x and y coordinates, what will be them? This is the reference of, this is the origin of this the space I oriented. This is the origin here. It means that at time equals to 0, the particle is at the origin. What is the coordinate of the origin? 0, 0. You understand what I'm saying? So I'll explain it better when we shall be doing projectiles, because I saw that you were a bit confused when questions became a little bit tricky in projectiles. When I will do that, I think you have a perfect mastery on how to orient space, and on how to determine the initial conditions of the particle. So firstly, for as a reminder, you orient your space afterward, determining the direction of motion. Here, our direction of motion was downward. So I will orient my positive y in the downward direction. And for x, I orient it how in this direction, basically how I want, but I'll put it in this direction. You understand? You put your y, you put your x. You always put your axis at the level where the particle starts the motion. Because in an exercise, they can say that they can ask you, they can in an exercise, they can precise that the origin of reference is on the floor. So it means you shall put your origin of reference on the floor. But here, nothing is mentioned. So you choose your origin of reference as you want. And the best way to choose it is to always put it where the particle is starting the motion. You understand? So this is where I place it. I put my y here, x here. Don't forget to always put your I vector here and your j vector in the j direction. So let's move to the next question. The next question, we have to prove that 2gt equals to 2g capital T equals to 1 on k ln of the absolute value of 5 on 3. So that's what we're supposed to prove. Okay, from our equation 2, we had what? Let me go back to my equation 2. We had g into 1 minus k square v square equals to a. Okay, we had g into 1 minus k square v square, k square v square equals to a. Is that okay? Now, our aim here is to prove this, and I told you that there is time here. That's what is supposed to orient you. There is time here, so I have to write my acceleration in terms of time, because I know that there is already time here. So I have to bring out an expression of acceleration that relates times to something. And we know that acceleration is equals to what? We know that, recall, let me write this, recall that acceleration equals to what? dv on dt. Is that okay? dv on dt. So this implies I'll have g into 1 minus k square v square, which will be equals to dv on dt. So there are d's in front of v and a d in front of t. So the variables are v and t. Is that okay? So what I will do is that I'll bring like terms together. Terms, since this is dv, I'll bring terms in v to this side and the dt to the other side. This implies I'll have g dt, which will be equals to what? Will be equals to dv on what? On 1 minus k square v square. Is that okay? Okay, from here we basically need to remove the d's. Is that okay? To do that, we have to integrate. Before integrating, what we are supposed to do is to find initial conditions and final conditions. Is that okay? We know that at t equals to 0, the variables are time and what? Are time and velocity. At t equals to 0, t initial was equals to what? 0. Initial time at t equals to 0, t initial is what? 0. And what is v initial? V initial, the initial velocity, v initial, which is equals to u, was equals to what? The particle is leaving from rest, was equals to 0 meters per second. Is that okay? Now, at t equals to capital T, what is T final? T final is what? Capital T. Is that okay? And V final, which is the final velocity, was equals to what? The final velocity, let me go back, at T equals to capital T, V was equals to 1 on 4k. V final was equals to 1 on 4k. Is that okay? We have already our initial and final, we have already our conditions at time equals, we have already our initial and final condition. So this implies the integral from t initial to t final of what? G dt must be equals to the integral from v initial to v final of what? dv on the 1 minus k square v square. Is that okay? So I'll substitute things. So this we are going to have the integral. T initial is 0, t final is capital T g. Let me put the g, since g is the acceleration due to gravity, is a constant. Let me put it outside. G dt must be equals to integral. V initial is what? V initial is 0 and V final is 1 all over 4k. Is that okay? dv on what? 1 minus k square v square. Is that okay? Perfect. I'll simplify this other side. I'll integrate this later. So this implies I'll have the integral of dt is t. So I'll have g into what? T, small t, going from what? 0 to capital T, which will be equals to integral from 0 to 1 on 4k dv on what? On 1 minus k square v square. Is that okay? So when we shall substitute the upper and lower bound here, we are going to simply have we are going to have capital T minus 0. So this will simply give G capital T being equals to what? The integral from 0 to 1 on 4k dv on the 1 minus k square v square. Now, this is the question you are supposed to ask yourself. How do I integrate dv on 1 minus k square v square? How do I integrate this? How do I integrate this? This is very simple. It's very simple. This is a constant. This is a constant. So it's basically like they're asking you to integrate 1 dv on, let's say this constant was equals to, let's say for example 4. Let's say even 2 was equals to 2. So we are going to have 2v squared. Is that okay? Now, what are you supposed to do? To integrate this, this is a difference of 2 square, because this is 1 square minus the square root of 2 square v square. So I just write it. If I write it in difference of 2 squares, I'll have 1 minus the square root of 2v into 1 plus the square root of 2v. So you are basically going to have what? Dv on the 1 minus the square root of 2v into 1 plus the square root of 2 what? V. So how do you integrate this? To integrate this, we have already seen it. We have already seen how to integrate such things. We have seen it. You basically need to do what? Express this in partial fraction. You express 1 on the 1 minus root 2v into 1 plus root 2v into partial fraction, and you integrate. Is that okay? So that's what we're we're going to do here. So you see that in this resistive motion problems, there is a lot of integration inside. So you have to master your techniques of integration. Do you understand me? So let's proceed to this. So this implies I will have this implies I'm going to have gt being equals to what? Integral from 0 to 1 on 4k dv on what? So this will become 1 minus kv square. Is that okay? 1 square minus kv square. Is that okay? So this will become, this is already a difference of 2 squares. This implies gt will be equals to integral from 0 to 1 on 4k dv on what? 1 minus kv into 1 plus kv. Is that okay? And remember, k is a constant. K is a constant. So we have to integrate. So our main problem is to find this integral. So as I told you, to integrate this, we first need to express this in partial fraction. So let's first express 1 on the 1 minus kv into 1 plus kv into partial fractions. Okay, this is, look, if k, they said that k is a constant, so the variable is v. What is this? This is a linear expression. This is also a linear expression. So so these are two linear expressions. You understand? So it implies, so let's express this in partial fraction. So 1 on the 1 minus kv into 1 plus kv must be identical to what? These are linear expressions because k is a constant and v is the variable. These are linear expressions. So they are of the form ax plus b. Is that okay? So this will be equals to a on what? 1 minus kv. Is that okay? Plus b all over 1 plus kv. Is that okay? Now, this implies 1 all over 1 minus kv into 1 plus kv will be identical to what? I'll do the LCM here. naturally the LCM will be 1 minus, and you should understand that the LCM here has to be the same thing here. So instead of thinking too much, you know what will be the LCM, you just copy what is under here, you put it here. Is that okay? So we're going to have 1 minus kV into 1 plus kV. This divided by this, we're going to have A into what? 1 plus kV plus this divided by this will be B into 1 minus kV. Is that okay? So we see that this is identical to this. The denominators are identical. So for this to be identical to this, what does it mean? It means that this numerator has to be identical to the numerator here. So this implies 1 must be identical to what? A into 1 plus kV plus B into 1 minus kV. Is that okay? Now we have to simplify this system. Look at something. Instead of developing everything, you understand, that's a wastage of time. So because these are linear expressions, if I find the roots of this, if I solve, for example, 1 plus kV equals to 0, this is something you are supposed to do in your rough work. It means that kV will be equals to minus 1. This implies V, because don't forget V is the variable. V is the variable, K is a constant. This implies V will be minus 1 on the K. Is that okay? The same thing if I find the root of this, 1 or yes, the root of this or the 0 of this, 1 minus kV equals to 0. It implies kV will be equals to 1 and V will be equals to 1 on K. So to simplify this system, I'll start by saying when K, because when K will be equals to minus, when V will be equals to minus 1 on K, if I substitute minus 1 on K here, K will go out and will be left with 1 minus 1. This becomes 0, and here this will not disappear. It will be capable of finding B. Is that okay? When V equals to minus 1 on K, what do we have? We're going to have 1 being equals to what? I'll have A into 1 plus K into minus 1 on K. Is that okay? Plus B into 1 minus K into minus 1 on K. Is that okay? So this K and this K will go, and this 1 minus 1 will make, this will become 0. Here this K and this K will go, and here we're going to have what? We're going to have 2. So this implies 1 will be equals to what? 2B, implying B will be equals to what? A half. Is that okay? So we have already our B. Now let's find the other one. When V is equals to 1 on K, V is equals to 1 on K, what do we have? We have 1 being equals to, we substitute here, we're going to have A into 1 plus K into 1 on K plus B into 1 minus K into 1 on K. Is that okay? This K and this K goes. We'll be left here with 1 minus 1, which is 0. So this B will go, all this term will go, and here we shall be left with this K and this K goes, and we'll be left with 2A. So this implies 1 will be equals to 2A, implies A is equals to what? A half. So we have already our A and B. Is that okay? We have already our A and B. So this implies 1 all over 1 minus kV into 1 plus kV is identical in partial fraction to what? A and B I have is equals to half all over 1 minus kV plus a half all over 1 plus kV. Is that okay? So so in partial fraction, so this implies 1 all over 1 minus kV into 1 plus kV in partial fraction is identical to what? is identical to a half. A half is identical to 1 all over 2 into 1 minus kV plus 1 all over 2 into 1 plus kV. Is that okay? So we have already expressed this in partial fraction. So we are going to come and substitute. So this dV, so this, we are going to replace what? This dV, this, because this is like 1 on 1 minus kV into 1 plus kV times dV. Is that okay? So we are going to replace this by its partial fraction form. So this implies, let's call this step equation 1. Yes, let's call this equation 3. Is that okay? So it implies from equation 3 we have G capital T being equals to what? Being equals to what? We are going to have the integral from 0 to 1 on 4k into what? We are going to substitute this by this into 1 all over 2 into 1 minus kV plus 1 all over 2 into 1 plus kV. Is that okay? All that times what? Look at this. Times dV. Is that okay? That times dV. Very good. So this implies our G capital T will be equals to we're going to arrange things. So this becomes a half into the integral of what? From 0 to 1 on 4k, from 0 to 1 on 4k, dv on what? 1 minus kv plus what? A half integral of what? G from 0 to 1 on 4k, dv on what? 1 plus kv. Is that okay? Perfect. So how do you then integrate this? How do you integrate this? You know that it's like, how do you integrate this? It's very simple. You understand now? It's very simple. What are we supposed to do here to integrate this? We notice that in this first part, we notice that d of this will be equals to what? If we differentiate with implicitly with respect to v, we know that d. So this is what I will do. So we notice that that's why I'm saying revise very well your integration, and I'm going to continue because I've not yet finished that chapter. I'll continue with the lectures. So we notice that what do we notice? D of 1 minus kV is equals to what? When I differentiate this is 0. When I differentiate this with respect to v, this becomes what? This will be minus k dv. Remember, k is a constant. We also notice that d of 1 plus kv is equals to what? K dv. Remember this formula, d of f of x equals to what? F prime of f of x dx. Is that okay? So when we notice already this, it simply means that, but look at something. Here we have dv already up here. So it means that we are supposed to multiply this integral top and bottom by minus k, and this integral top and bottom by what? K. Is that okay? So this implies capital GT, G capital T will be equals to a half integral from 0 to 1 on, pardon, I made an error. So this will be equals to, I'll multiply this integral by minus k. Is that okay? So this becomes a half times minus k on minus k integral from 0 to 1 on 4k dv on 1 minus kv plus this integral, we are supposed to multiply it by what? K. So this becomes a half k all over k integral of what? Dv all over 1 plus k v. Is that okay? I have the right to multiply an integral by constants but not variable. K is a constant, so that's why I have that right. So this becomes, it implies gt will be equals to what? Will be equals to, I'll make this minus k enter here. So this becomes minus 1 on the 2k integral from 0 to 1 on 4k minus k dv all over 1 minus kv plus 1 all over 2k integral of k dv all over 1 plus kv. Is that okay? Now, notice that this d of 1 minus kv was equal to what? Minus k dv. So we are going to substitute it here. And this d of 1 plus kv was equal to what? K dv. So we are going to substitute it here. So this becomes, so this implies g capital T will be equal to minus 1 on 2k integral from 0 to 1 on 4k to 1 on 4k d, this one is d of 1 minus kv all over 1 minus kv. Is that okay? Plus 1 all over 2k integral from, oh, the boundary 0 to 1 on 4k, 0 to 1 on 4k, don't forget 0 to 1 on 4k. Is that okay? Of this k dv is the same as d of 1 plus kv. Is that okay? All over 1 plus kv. Is that okay? Now, in both of the forms, we're already in the form where it's like we're integrating d of a big X all over a big X. So the integral here is ln of the absolute value of big X. Is that okay? So from here, this implies gt will be equals to what? Gt will be equals to gt will be equals to, so here I'm going to have minus 1 on 2k. Is that okay? The boundaries here are from this integral will give us ln of the absolute value of what? 1 minus kv. Is that okay? 1 minus kv. Is that okay? Boundaries going from 0 to 1 on 4k plus 1 all over 2k. Boundaries going from what? Boundaries, the integral of this is ln of the absolute value of what? 1 plus kv. Is that okay? Boundaries going from 0 to 1 on the 4k. Is that okay? Okay, very good. Now, look at something. Let me first factorize this guy outside, because this and this, look at something very well. Look at something very well. I want to arrange things first. I can directly substitute, it will give you the answer, but I want to arrange things first. So this implies g capital T. Let me factorize this and this one on the 2k. Yes, this one on 2k. I'll have 1 on the 2k into what? Okay, 1 into 2k, 1 on 2k. Let me see. 1 on 2k, yes. 1 on 2k into what? Here. And you see, what do you notice again? The boundaries here are common. So I can simply apply the boundaries. So wait, let me write this. No, let's go directly. Let's substitute. I wanted to show you something, but there's no need of showing that. So let's substitute the boundaries. So here I'm going to have, let me factorize first of all. Okay, let's go directly. This will give minus 1 on 2k. Is that okay? I'll have my big brackets. The upper bound here is 1 all over 4k. Is that okay? So I will have ln of the absolute value. ln of the absolute value of what? 1 minus k into 1 all over 4k. Is that okay? Minus, let me put, there is the absolute value here, don't forget. Minus the lower bound. So I substitute the lower bound here. This will give into ln of the absolute value of what? When I substitute 0 where there is v here, because v is the variable, this gives 0, so I will have ln of the absolute value of 1. Is that okay? Plus what? This other one, 1 all over 2k into what? Let me substitute the upper bound. I'll have ln of the absolute value of 1 plus k into what? 1 all over 4k. Is that okay? Minus the lower bound, ln of what? We substitute ln of the absolute value. We substitute the lower bound. When we substitute 0 where there is v, this becomes, there will be 1 that will be remaining. So I will have ln of the absolute value of 1. I close this. Is that okay? Now, this gives 0, this will give 0, and this will also give 0. Is that okay? So I will have gt, g capital T, being equals to what? So I will have minus 1 on 2k into what? Into this will give 0, because ln absolute value of 1 is 1 and ln of 1 is 0. So here this k would go with this k. So I will be left here with what? Ln of the absolute value of 1 minus 1 on 4. Is that okay? Plus 1 all over 2k into what? Ln of what? Of the absolute value. This gives 0. This k and this k goes, so we shall be left with ln of 1 plus 1 all over 4. Is that okay? Okay, perfect. So this implies our g capital T will be equals to, let me first simplify this. I'll have minus 1 all over 2k ln of the absolute value of what? Ln of the absolute value. 4 times this will give 4, minus this gives 3 on 4. So I'll have 3 on the 4, absolute value of 3 on 4, plus 1 all over 2k ln of the absolute value of what? This times this 4 plus this 5. So I'll have 5 all over 4, absolute value of 5 on 4. Perfect. So let me factorize the 2, the 1 on 2k. So this implies g capital T will be equals to 1 all over 2k into what? Ln of the absolute value of 5 all over 4 minus ln of the absolute value of what? 3 all over 4. Is that okay? Perfect. So this is what we have. So we recall that ln of A minus ln of B is equals to ln of A all over B. Is that okay? So here we are going to have, and recall also that the absolute value of A all over B is equals to the absolute value of, is equals to the absolute value of A all over the absolute value of B. Is that okay? So here we are going to have, this implies G capital T will be equals to 1 all over 2k into what? Ln of what? We are going to have absolute value of 5 all over absolute value of 4 divided by absolute value of 3 all over the absolute value of 4. Is that okay? So this is what we're going to have. So this becomes, it implies gt will be equals to 1 all over 2k ln of what? Absolute value of 5 all over absolute value of 4 times what? Absolute value of 4 all over absolute value of 3. So this one and this one are going to go out, and we shall be left with gt being equals to 1 all over 2k ln of the absolute value of what? 5 all over the absolute value of 3, because this gives absolute value of 5 all over absolute value of 3. And using this property, we know that absolute value of A all over absolute value of B is equals to the absolute value of the whole A on B. Is that okay? Now, what was the proof even? The proof was that 2gt must be equals to this, so we just have to bring our 2 the other side. So this implies our 2g capital T being equals to 1 all over k ln of the absolute value of 5 all over 3. Perfect. Is that okay? If at this stage you can even remove the absolute value of 5 on 3 is what? 5 on 3. So this is also the same as 2g capital T being equals to 1 all over k ln of what? 5 on 3. So that was basically how you are supposed to do this question. So what did you notice here? You notice here that we were faced with what? Integrating this. Integrating this. This is the same as integrating ax plus b into, let's say, alpha x plus beta plus beta. These are linear expressions. How do you integrate this? You first express this in partial fraction, because in the assignment that I gave you, remember the assignment that I gave you, where I asked you to find how do you integrate capital A on ax squared plus bx plus c. The first thing you are supposed to do is to calculate delta. Let's say delta is greater than 0. It simply means that this quadratic expression is going to have what? Two real roots. Is that okay? So the two real roots will be x minus alpha 1 x, the two factors will be x minus alpha 1 and x minus alpha 2. So this is replaced by this, and you simply express what? This in partial fraction. That's the same thing here. That's the same thing here. Is that okay? So to integrate this, we had to first express this, because v is the variable. V is the variable. We just have to express this, and k is a constant. We have to express this in partial fraction. Is that okay? And there is also a very important thing here. You have to know, don't be confused. To have to simplify things here, just solve this as you always do the other ones in your rough work. To find the roots, you solve this being equals to 0, you have the root of this. Solve this being equals to 0, you have the root of this. You have your v here and your v here, and you proceed to finding what? You proceed to finding the solutions. Is that okay? So that was all for this question. That was all for this question. I hope you try to master all what was being done. So try to go all through the question. Try to go all through the question. So try to go through all these questions. So this was a very simple question. Very simple question. Try to go through all the question. Try to go all through the question. Yes. Let me go down gradually. Yes. Try to go through. Where you don't understand, you can ask me question in the group. Yes. Go through the question. I'll put the video now on YouTube. So you go through the question and try to master everything. So this was a very simple question. So don't be afraid of such questions. I know that your problem here was integration, and you see that basically there was nothing very complicated. There was nothing complicated to make. It was not really a complicated integral. So go through the question, and the important hint I explained here. The proof was this. I noticed here there was time here. So my main aim was to write acceleration in terms of time. My aim was to find an expression of acceleration which contains time related to something. So see you next time for other exercises.